Welcome to your physics update. I'm Brianna Montecavo, and let's start off with Newton's first law. Newton's first law states that an object at rest will stay at rest and an object in motion will stay in motion unless acted on by an outside force. If no force is occurring, an object will want to stay where it is. This is the basic principle of inertia. As you can see in the video clip, the curling puck stays in a straight line path until it hits the other curling pucks. Once a connection is made, the direction and speed changes of both curling pucks. If there was no contact, the puck would continue to move on until acted on by a different force. Now let's head on over to baseball with Newton's second law. The second law states that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of the object. If you exert the same force on two objects of different masses, you will get different accelerations. Watch in this clip how the batter is constantly hitting the baseball. With the amount of force the batter is applying to the ball, it would be going further, but the pitchbacks are creating another force which propels the baseball off. This also relates to Newton's first law because the ball wants to stay in motion, but the pitchbacks cause the ball to change direction. Watch as the batter follows through. By following through, he can hit the ball in such a way that it leaves the bat with more velocity. Oof, would you look at that. Now up next, Newton's third law. Newton's third law states that for every force, there is an equal and opposite reaction force. Acting forces encounter other forces in an opposite direction. All the reactions need to happen in pairs because there needs to be an opposite force acting on the object. In these video clips, you see football players being hit with an equal and opposite reaction force. The player being hit is in motion, while the player who attacks uses such a big force in the opposite direction, they both end up falling with the football flying. In all the clips, both players end up falling because of the extreme forces in different directions. Now, after completing Newton's laws, let's go into objects in freefall. An object in freefall is completely under the influence of gravity. Any object that is being acted upon by only the force of gravity is said to be in a state of freefall. A free-falling object accelerates at 9.8 meters per second squared. In the clip, the two skydivers seem to be just floating in the air. The divers aren't plunging to their death because of gravity pushing them down, but the air pushing them up. If there was no gravity, the divers would fall at a quicker rate. The release of the parachute halts the acceleration and causes the velocity to slow down, so when the skydivers approach the earth, they are able to walk away instead of being scraped up off the ground. Last but not least, our clip on centripetal acceleration. In centripetal acceleration, the tangential speed is constant, but the direction of the tangential velocity vector changes as the object rotates. This is shown in the equation when the tangential speed squared is divided by the radius. If an object has centripetal acceleration, they must be rotating on an axis. The centripetal acceleration's direction is always inward. Watch as the figure skater brings her leg near her face. By keeping her body parts close to her, she is able to spin faster. This also relates to the conservation of momentum because as the skater is keeping her body close together, she is conserving her momentum, so when she finally stops, she is able to continue skating with a new amount of force. Thanks for watching Physics Update. I'm Brianna Montecavo, and good night, everyone.